Hey everyone, my name is Christian Ensoar Santa Cruz, a computer science student at Camarines Sur Polytechnic College, here to talk about the lists of data structure and algorithms. But first, what comes to our mind when we say the word list? A couple of examples of a list could be a grocery list used for shopping, a student list owned by a teacher, a personal to-do list, or kahit yung listahan ng utang ng mga kapitbahay nyo ay isang example ng list. The definition of a list is a type of linear data structure, which means that its elements are stored in a sequence, one after another. In a linear structure, each element has a unique predecessor and a unique successor, except for the first and last elements. This makes traversal straightforward, as we can visit elements one by one in order. In this tutorial, you will learn how to manage a simple student record system using Python and NumPy. You will also see how this program implements a linear data structure system using arrays where data is stored in a sequence and accessed by positions. First, we import NumPy, which is a powerful library for working with arrays. We then define a custom data type called student_dtype, which has two fields, name as a string and score as an integer. After that, we create an empty array called students, where we will store all the student records in a linear order. Let's first take a look at the insert functions. Define add student at the start inserts the user's input at the first position of the list, while define add student at the end inserts the user's input at the last part of the list, while define add student at position inserts at any chosen position in between. This shows how arrays handle insertion in a sequential manner. Now let us move on to the delete functions. We can remove elements from different parts of the sequence. Delete student start removes the first element of the list, and delete student end removes the last part of the list. Delete student position removes an element at a specific position, while delete student score removes by value, in this case using the score field. This demonstrates deletion in a linear structure by shifting elements in the array. Now let us move on to the search and display. In linear arrays, we can search and assess elements directly by their position or value. Search student looks for a student's name. If they are not in the list or the list is empty, they will notify the user that the list or the name of the student is not in the list. Display student position retrieves a student's index. Display list shows all students in sequence, one after another. This highlights how linear structures maintain order for easy traversal. The main menu. To make everything user-friendly, the program uses a menu loop. It gives options from 0 to 10 for inserting, deleting, searching, or displaying students. Since arrays are linear, each operation works in a sequence, preserving order. The program only ends when the user selects option 0 and types in the authentication of confirm. Now that we have created our code, let's find out if it runs correctly. Hey everyone, before we start the video, just a gentle reminder, I am not a professional programmer, I'm a student. I've encountered many errors and problems in the making of this Python program, and everything I've learned and applied came from a lot of YouTube tutorials and online resources across the internet. So without further ado, let's get started. Hey guys, this is now the run code of the student ranking system. Unfortunately, I'm not able to use screen recording since my laptop lags when it's connected to the internet. I need to still download the software in order to screen record, but I'm using my iPhone to have the best quality available. So yeah, let's get started. Let's first try insert at start. So as you can see in the video, insert at start allows us to insert an element in the start of the list. So when we input 1, it asks us for a name. Let's add Enzo. And it's going to ask for a score. Let's add 99. Now the system says that it has successfully added Enzo with a score of 99 at the start. So when we press 10, it shows us the current list, and fortunately we can see that Enzo 99 is at the start of the list, which is in position 1. So we can say that the code in insert at 1 start is working. Now let us go to insert at end. Insert at end is similar to insert at start, but instead of position 1, it goes to the last position available. So in this case, when we insert at end, it should place the next student at the position 2. So let us put 2 in the input, and then it's going to ask for a name again. Let's add Enzo number 2 and another score, which is 98. Now it says that Enzo 2 with a score at 98 was added at the end. So when we see the current list of students, we can see that Enzo number 2 is at the second position beneath Enzo. Now how about we put someone in between? That is made possible in use of insert at position. Insert at position can add an element in the first, last, or any position in between. So let's add 3 to the input. Let's add Enzo number 3. It's going to ask for a score again. Now let's put 97. Here, it's going to ask for us for the position. Like I said before, we can either add it in the beginning, the end, or in the middle. For in this case, we're going to put him in the middle. Now you can see that successfully added Enzo number 3 with a score of 97 at position 2. And when we see the current list again, we can see that Enzo number 3 is indeed in the second position where Enzo number 2 was with a score of 97.